in fact, moderator basically is a third variable that basically either strengthens or the, weakens the relationship between two variables. Here, there are two important things to be discussed. First one is the direction, okay? Direction doesn't mean that, the relationship originated, the origin of relationship or it changes. Rather, it means either the relationship becomes positive or the relationship becomes negative. Okay, sometimes maybe it might be like, here in the specific screen, as you see that the direction of arrow is from independent variable to the dependent variable here. So some people might perceive that by direction, it means that now the arrow will turn back from DV to IV. It is not the case, okay? Here the term direction, it means that either the relationship is positive and when the moderator, it basically moderates the relationship, the positive relationship turns into the negative or the vice versa, okay? So an alternative, research mechanism that is also most frequently, one of the most frequently investigated research mechanisms in the domain of social sciences, that is the mediator. And mediator basically is a third variable that strengthens the relationship between two variables, okay? And in fact, in the research domain, the key thing is that we have to learn to differentiate between a moderator and mediator. We don't have to confuse these two concepts. Initially, it becomes very difficult for these scholars of research to basically develop their understanding about, about the distinction between moderator and mediator, okay? So in simple, basically, the moderator, it basically emphasizes on the when certain effects will hold. Its focus is the when aspect of the relationship between two variables. Means when some, it explains the situation or the circumstances under which a relationship may either hold or may not hold. On the other hand, the mediator, it basically emphasizes on the how or why aspects of the relationships. Okay, here these two concepts are basically, this is the graphical, on the specific slide, this is the graphical representation of moderation and mediation. Okay, here you can see in diagram A, this is basically this is an example of the direct effect here. Sorry. This one is basically this specific diagram. It is representing the direct relationship between two variables. This is also example of a very simple mechanism, very simple, because the relationship exists only between two variables. Okay, but here when we look at the the models which are drawn on be these moderation models. Okay, here we can see the relationship is not limited to between two variables only. Rather, there is some third variable that is basically affecting the relationship between two variables. Okay, and the models, these three specific models drawn here, they are basically representing, they are the graphical representation of the moderation analysis. A moderation, in certain domains, okay, just like economics and finance, okay, these scientists, they have a habit of, representing their models in the form of equations, okay? But here in behavioral sciences or in psychological sciences, we have a habit of, representing our models in the form of some such kind of graphical representations. So this is basically a graphical representation of the moderation models. Okay, here you can see there is a variable x1 and there is a moderator, it is called x2, and that is also affecting the dependent variable. Okay, and when these x1 and x2, they interact with each other, okay, and to affect the basically relationship of to affect the dependent variable. Okay, this is another graphical representation of the moderation analysis. Here we can see that x1 is basically related to y1 y. On the other hand, there is a third variable, that is x2, that is moderating the relationship between x1 and y. Okay, and the equations in here we can see, you know, there are three different paths which appear. Okay, and x1, it is basically the predictor. Okay, and the relationship between predictor and the outcome variable, or if you consider it in the example of x1 and x2, x1 is the predictor and y1 is the outcome variable. Okay, and the relationship between predictor and the outcome variable, it is represented by, you know, a path that is called path A. This specific third model, it is representing the path diagram of moderation analysis. Okay, and then there is path B, and that path B is it basically represents the relationship between moderator and the outcome variable. Okay, and then there the interaction between, you know, a predictor and the moderator, it is represented by path C. So if we draw the equations, we have to draw three different equations. One equation is for predictor to outcome variable, the second one is from moderator to outcome variable, and then we multiply our the predictor and the moderator with each other, and then we regress it on the outcome variable. Okay, and in this third diagram, this is basically the graphical representation of the mediation model. Okay, here you can see it is, this mediation model is completely different from the moderation analysis. Here two variables are directly connected as well as they are also indirectly connected. So in fact, mediator, it basically serves as a booster of the relationship between independent and the dependent variable. Okay, on the other hand, the the moderator, it basically serves as the regulator of the relationship between two variables. So in this specific context, the mediator can be known as either a regulator or an interaction effect, or there are different multiple alternative names of the moderation mechanism, moderation analysis, right? And it is normally tested by multiplying the independent variable or predictor with the moderator. Okay, and there's one question that might arise in the mind of the of the students, is that how can we know that either x2 is moderating the relationship between x1 and y significantly? Okay, and the answer is that in fact it is basically the interaction term that basically if you find the interaction term significant, then this is an indication that the moderation analysis has remained significant. Okay, so the only condition in moderation analysis is that the interaction term must be significant. Okay, we shall discuss this later in the further discussion as well. Okay, so far, if maybe majority of these students, particularly the novice PhD scholars, they have confusion that either it is important that the predictor or the moderator, both of them have to be significantly associated with the outcome variable. In fact, the truth is that in fact no, that it is not necessary. Even if either they can, the predictor independent variable, it can be significantly associated with the dependent variable, or the moderator can also be significantly related to the outcome variable. But there is another condition, that is, the relationship, there is no relationship, significant relationship between predictor and the moderator. So if you have to differentiate between a mediator and the moderator, okay, then it is that first of all, the moderator and predictor should have no significant relationship with each other. Okay, just like if I draw an arrow here, okay, this relationship should not be significant. Okay, and the another condition is that the interaction effect, this predictor multiplied by moderator, it is called interaction term or interaction effect. This interaction effect should be significant. Okay, so we can simply differentiate between moderation and moderator and the mediator based on two different conditions. The first one, the relationship between predictor and the moderator should not hold significant. The second thing is the interaction term between predictor and the moderator must be significant. So this is the condition of the moderation analysis. Okay, just like here, you can see in the mediation, in this specific mediation models, this drawn here, you can see that mediator and the predictor both are related with each other. Okay, but in case of moderation here, we don't see any significant relationship between them. This relationship should not be significant. If this relationship is significant, this is an indicator that this third variable should either act as a mediator between these two variables, or it must act as a suppressor. Suppressor is a new kind of research mechanism that has been recently presented by some researchers. Okay, and maybe only few scholars, they have knowledge about the suppressor effect. Okay, we can discuss the role of suppressor effect in different talk or different discussion. Okay, so I'm repeating again that the key distinction between mediator and moderator is that the moderator and the in the moderation analysis, the predictor and the moderator, they do not have significant relationship. Plus, there is a condition that this interaction term that is computed by multiplying the predictor with the moderator, this interaction term should be significant. This is the important condition for the when you find this interaction term significant and you find no significant relationship between predictor and moderator, this is an indication that this third variable is serving as a moderator between any two relationships. In social sciences, the mechanisms, they become more complex. So when we develop our understanding about the role of any third variable between the relationship of two variables, it provides us some new insights that how a specific phenomena might be occurring. So it enhances our understanding about the psychological, more complex psychological or social mechanisms. So that is why moderation is an important topic of discussion. Okay, so a lot of students or scholars who have been basically working on the different kind of, who have been testing different kind of moderation hypothesis in their research dissertations or the research projects. Okay, they might have a question in their mind that why we have to go we have to know about different approaches which can be used for testing the moderation effect. It is possible that majority of us, when we are novice, we become habitual of testing using only single method for performing moderation analysis, and this is something that at various times we can that could lead us towards some kind of mistake. Okay, because for a variety of reasons. The first one is the nature of hypothesis or the researcher's interest, it might differ. For example, in social sciences, we divide statistical techniques into two different groups. Okay, the first group is basically, the first group of statistical techniques is used to test the hypotheses which are based on the relationships between two variables. For example, we can say that intelligence is positively associated with the academic performance of a student. Okay, so in fact here in this specific scenario, we are interested in understanding the relationship between intelligence of a student and his academic performance. Okay, but there could be some other type of hypothesis as well. Okay, and the second group of statistical techniques is used to test those kind of hypotheses, and that kind of hypothesis, they are based on differences among different groups. For example, we might be interested in how the academic performance of male students and female students, they differ from each other. So male versus female, that is just, that is one, that specific, you know, uh, uh, this different distinction comes under one, you know, it is known as gender. So based on the gender, we can divide our students into two different groups, that is male versus female, and we are interested in making comparison in their academic grades. So when I talk about the nature of hypothesis, okay, the researchers might be sometimes interested in understanding the relationships between variables for the purpose of prediction, and in other situations they might be interested in understanding the differences between two or more groups, okay, of the participants, okay. So that is why this is one of the important reasons that we have to take care into, you know, while performing our moderation analysis. For example, if we are interested in prediction or understanding the relationship between two variables, the most appropriate technique is to go for some, you know, a regression based method, okay. On the other hand, if we are interested in understanding the differences between you know, different groups, so we have to think about t-test, we have to think about the ANOVA or other kind of you know, statistical techniques which basically enable us to understand the differences among different research groups, okay. The second factor that is important to consider the alternative approaches for moderation analysis is basically the nature of the variables, okay. Sometimes our variables and are categorical in nature, okay. In other cases they are, you know, ordinal. In other situations they are scale type of variables. So in fact we have to choose the appropriate technique for the moderation analysis based on the nature of the variables which we have basically used to nature of the you know, variables which we are using, okay. For example, for the gender is basically a categorical variable. It consists of male versus female, so we can divide it into two different groups, one, and we can assign them value of 1 and -1, okay. So the nature of the gender variable is categorical in nature. So when we are interested in basically determining the difference in the academic performance of male and female students, okay, we have to go for basically t-test or some other relevant technique rather than using regression analysis, okay. On the other hand, when we are interested in, for example, we are interested in examining the you know, relationship between level of intelligence of the students and their level of academic performance. So it is important, the more appropriate suitable technique is basically the regression based moderation testing mechanisms, okay. So in the you know, crux of the debate is that we have to select the suitable and the most appropriate techniques for, depending upon the nature of the data that we are basically that we are holding, okay. Third point for which we need to consider about the multiple, we need to learn more about the, you know, use of alternative approaches of moderation analysis. It is the disciplinary background, okay. Maybe some researchers, they belong to specific, you know, background, and they are more attuned to basically they are more habitual of using a specific kind of technique rather than the other one, okay. So when a student brings analysis, moderation analysis based on some you know, some technique that does not specific that's not specific to that specific discipline, then the audiences or the judges, they may not be happy with this kind of analysis. So I also relate this point to the normative requirement of the discipline, okay. In certain disciplines they prefer using certain techniques, while in other disciplines they avoid using some specific techniques. On the other hand, the editors or reviewers, they might also have their own specific interests. Editors may find your paper you know, very good, but maybe he doesn't like the way you have performed the analysis. And same is the case with the reviewers. They have been, you know, in today's time, you know, the reviewers they are using certain techniques while they are not, you know, for example, your professor may, you know, encourage you to use to rely on only two-stage approach of moderation analysis rather than the, you know, the other hierarchical moderation analysis or the ANOVA. Okay, so we have to take care of those specific aspects as well. When I talk about the disciplinary background, for example, in behavioral sciences or the in psychology, okay, in human resource management discipline, we use the measures which could be, which may have variety of natures. For example, we may have reflective measures of we in sometimes we use reflective measures for measuring some variables. On the other hand, we use the you know, formative measures. Okay, similarly, we can also use the multi-dimensional constructs. On the other hand, in other disciplines, for example, in economics or in engineering, they use the variables which basically satisfy the condition of singularity. That is one of the, you know, requirement of the of the regression assumptions. Okay, so we have to take care of the disciplinary background as well. So in fact, we have to consider all these 5 points. Okay, nature of the hypothesis, nature of the data, the disciplinary background, the normative requirements of your discipline, as well as we also have to respect the editors or reviewers background. They might be more comfortable in using certain techniques because they might find those techniques more robust and rigorous as compared to the other ones. So you have to, and the second thing is they are judges of your, you know, research, you know, outputs. So that is why we have to respect their, you know, their point of view as well. Okay, in this specific domain. So in today's discussion, I'm going to introduce you with variety of alternative approaches, you know, for the purpose of performing moderation analysis. Okay, and these approaches are listed here on this specific screen. The first one is the stepwise regression analysis. Stepwise regression analysis, it is also known as hierarchical moderation analysis. Okay, the second technique is the two-stage approaches. Okay, here product indicator and orthogonalization, these are two different approaches which may be considered under the domain of you know, product indicator, or which under the domain of two-stage approaches. The third type of technique that is you know, used is the mode probe. Okay, and this technique has now become part of the process macro. Previously, Preacher and Hayes, they had already developed a plugin for this. Okay, that is also available. The fourth technique is the ANOVA. ANOVA has certain advantages, and it can offer the, it can also provide the similar kind of you know, moderation analysis opportunities. Okay, the and the fifth approach is the group analysis. Okay, sorry, group analysis. This is the fifth approach. So in fact, the variety of alternative approaches which can be used for the purpose of performing moderation analysis are given here. Okay, so let me introduce you with these techniques one by one. Okay, the first, let's continue the first approach, that is called as hierarchical or multiple moderation, hierarchical moderation analysis, or the stepwise moderation analysis. Sorry, this is a mistake. Okay, here hierarchical mod, this it is hierarchical moderation analysis regression. This is a typographical mistake, or it is called stepwise regression. Stepwise regression. Okay, sorry for this mistake. Anyway, so in fact, so I will continue. In what we do in this specific approach of performing moderation analysis, this is, as it is evident from its name, stepwise. So in fact, what happens, we introduce each variable one by one in form of different steps or sequences. Here you can see on the right side in the diagram, you can see that the first model, in the first model, we are entering only one variable in this specific equation. Okay, while in second model we have entered another variable, and that variable is moderator. Okay, and then in this third model, we can also introduce other moderators or control variables or the interaction term. Okay, so what happens as we add one variable, okay, in the equation, the model becomes more complex. Okay, so here you can see the first model was very simple. There was only one variable. In the second model, we introduced we included the moderator in this specific equation, and the model became relatively more complex. And then in the third equation, we added some more variables in the specific, in this specific analysis. So I also want to give you some, practical demonstration of this specific variable. The steps for which we can use for performing moderation analysis are given here in this specific slide. Okay, for a quick preview, I will take you towards towards the Excel file which I have basically prepared for today's session. Okay, so here you can see the steps which are used for performing moderation analysis. The step one is we have to mean center both the independent or predictor and the moderator variable. So we have to mean center or we have to standardize, or in when we have longitudinal or panel kind of data, so we can also go for taking log or something, or differences, first difference, second difference as well. Okay, and the second step is to create an interaction term. This interaction term is basically created by multiplying the mean centered values of predictor and the moderator analysis, moderator variable. Okay, then in step 3 we enter these terms in the SPSS one by one. How there is a simple demonstration here. Okay, you can see I have prepared this file for the purpose of moderation analysis. The variables which I am using, they are workplace incivility and psychopathy. This workplace incivility, this is basically the incivility experienced by the employee of the organization, and psychopathy, this is a personality trait that basically this is kind of psychological disorder that the individuals might experience at certain times. Okay, so psychopathy, this is the we measure this variable with respect to the leader, and the incivility we measured it with respect to the employee. Okay, so we were basically interested in determining the moderating effect of bosses or leaders psychopathy. Okay, leaders psychopathy, psychopath personality, between the relationship of workplace incivility and well-being. Okay, so how shall we perform this specific analysis? Here we shall go to the we go to the analyze. Okay, in SPS, this is a simple demonstration. The further the the more detailed demonstration can be organized in other forthcoming workshops. Since this is the basic overview, so I'm giving a brief demonstration. So we go to the regression, we go to the linear regression, we introduce the dependent variable here, and then the basic purpose of this demonstration is to introduce you with how different steps are basically occurring. In this first step, for example, we can enter the independent variable. But here you can see this specific button is showing as I entered in workplace incivility values here. This button, the next button, it highlighted. So then in the next stage, I will basically enter the second variable, that is the moderator. This is the psychopathy. Okay, I have already created the interaction terms. Okay, by creating z-scores of these specific variables. So if I go stepwise here, okay, at the end of this document, you may see here that I have already standardized these variables and I have already computed their interaction terms as well, okay? And how we do this, we go to the descriptive statistics, okay? And we click on descriptive statistics, we enter these variables here, and we have to simply click here. And when we press OK, we will see that a new type of variables with Z, it is created in the specific document. So this column is representing the standardized scores of incivility. This column is representing the standardized scores of psychopathy. And we can multiply these two variables together by using the compute variable, tab. We can multiply them and we can give it a name. Here I have given it a name of interaction, okay? And then we press OK, and a new variable, that is interaction term, is created. Here, one thing that is important to remember is that we have to multiply the standardized estimates of the independent and predictor variable for creating the interaction term, okay? Then when we perform the regression analysis, okay, we enter these values one by one. First I shall introduce the standardized score of the independent variable, then I press next, then I enter the standardized scores of the moderating variable, okay? Then I press next, and then I introduce the third variable, that is the interaction term that we computed based on the multiplication of standardized estimates of independent and predictor variable. And then here we don't have to standardize the dependent variable here, okay? And then we go to the statistics. We simply click on these buttons. It's a quick demo, okay, for the sake of performing the analysis, okay? Here you can see, as I told you, that we enter variables step by step. I shall go to the coefficients, tab here. This is the most important tab. Here you can see that when we entered the first variable, it was only one variable that was computed. Then in the second model, we introduced the moderating variable in the equation. And then in the third variable, third model, we have all of these three variables in this specific. So here we have to consider only the interaction term. If the interaction term is significant, okay, we identify the significant from the significant values given here. If this value is less than 0.05 or whatever confidence interval you have set, okay, then your hypothesis will be supported, okay? This was a quick demo of the moderation analysis using stepwise regression analysis, okay? I will go back to the demonstration. Here we have already, we have already performed this specific. So in fact, according to these steps, in the first stage, we mean center values or standardize them, okay? And then why do we standardize? The answer is the collinearity, okay? Multicollinearity means the predictors should have no multicollinearity, the predictor and the moderator, okay? And then we create an interaction term. After creating interaction term, we enter variables in the SPSS one by one. And since we enter them one by one, that is why it is called hierarchical or stepwise regression analysis. Then we perform different kind of, relevant analysis, and we use the values for the purpose of, analysis, okay? The next approach is the product indicator approach. And this approach is normally used when we have latent variables, okay? In social sciences, in behavioral sciences, we are more attuned of using the latent variables, okay? Because the nature of variables that why do we use latent variables? That's a separate story. But in fact, in social sciences, the nature of the variables is different from the variables in the domain of other relevant, other pure sciences disciplines. So in fact, we have to basically determine a certain set of characteristics together. When these set of characteristics together, they are present in one specific situation, okay, we combine them and we label them as a specific variable. For example, if we talk about the personality and 5 dimensions of personality, you know it has 5 different dimensions, and every dimension has its own set of specific characteristics. Anyway, the simple answer, if you already know about the difference between latent variables and the observed variables, okay, you can easily pick that, you know, you can easily get the, understanding of this specific approach, okay. Here, this product indicator approach, this is used for the sake of latent, when we have latent variables with us, okay. In this specific approach, how we proceed, the idea is very simple, okay, and I'm again introducing you with this specific technique one by one, okay. The step 1 here, again, I'm using the same, I'm using same relationships. It is the same example. I'm using the same example, means we are interested in determining the impact of employee experience in civility on employees' well-being, and this relationship is moderated by the psychopathy of the leader, okay. So moderating role of psychopathy between work, employee experience in civility and well-being. These are the examples. Here I am using a different data file, okay. This one is given here. We use the latent variables, okay. Here, for the sake of simplicity, okay, the scales or measures which we used for determining the employee incivility and psychopathy, I have reduced them to 3 different, a set of questions or set of statements. So in fact, the latent variable of incivility, it consists of 3 different indicators or observed variables, okay. They mean, in simple terms, 3 different statements. Similar is case with the psychopathy, okay. So in this specific diagram here, you will see that, I have used psychopathy, this specific here, these 3 dimensions, these 3 different observed variables, they are basically attached to one latent variable, that is psychopathy. And similarly, we also have 3 items or 3 observed variables for the, latent variable of incivility, okay. So what happens in product indicator, okay? This approach is more easy to use in smart PLS and smart PLS software as compared to the other structural equation modeling softwares, okay, because they have they have used some background formulas to quickly calculate these interaction terms. But how things proceed, that is more important. Here in the first step, we standardized each variable, okay. In the first step, just like we standardized the variables in stepwise analysis, we have to standardize these variables. Once we have standardized, okay, we have to multiply them with each other, okay. How do we multiply? Here you will see, we have these variables here, these 3 items, they pertain to the workplace incivility, and these are related to the work psychopathy. So what happens here, we create, first of all, we standardize them. Once we standardized, we have to multiply each indicator of independent variable with each indicator of the dependent variable. So we have 3 observed variables for incivility. We have 3 observed variables for psychopathy. So at least we have to create 9 different interaction terms, okay. So how we create, we multiply wi1 with psi1, okay, and similarly we multiply wi2 with psi1, wi3 with psi1, and this is how we multiply them, all of these variables together, And how do we do it? We do it in SPSS. It is very easy to perform this specific action using the compute variable option here. So in simple, we have to multiply each indicator of these two variables with each other. Okay, so this will result in 9 different interaction terms. Okay, 3 by 3 multiply equals 9. So we have 3 indicators for psychopathy, 3 indicators for incivility. We have to multiply their standardized values with each other, and it will result in 9 different interaction terms. Okay, so step 1 is standardize each variable. Step 2 is, step 1 is standardize each variable. Okay, standardize each variable. Okay, step 2 is create interaction terms. How do we create interaction terms? By multiplying indicators of these two variables with each other. Okay, it will result in 9 different interaction terms. Here you can see they are all computed here. Okay, and then in the third step, we have to use all these 9 interaction terms as a separate, you know, as indicators of interaction term here. Okay, just like we created an interaction term in stepwise regression by multiplying the standardized values of moderator and mediator, we are also using the interaction term here. What is the difference? The difference is that here we are creating interaction terms by multiplying the indicators of both of the latent variables that we have used. Our independent variable is also latent variable. Our moderating variable is also latent variable, and both of them have 3 indicators. So when we multiply them, we get 9 different interaction terms, and we use these interaction terms as indicators of interaction term. Okay, and then we regress them onto the on the dependent variable here, as it is shown here. Okay, so all the steps of product indicator using latent variable approach, they are mentioned here. This is the second approach that we use in order to test the moderation interaction. Okay, in this file you can see that here, if it is, I hope it is visible, I have already created 9 different interaction terms here, and these interaction terms have been created by multiplying the standardized variables of the of these 3, W1, W2, W3, Psi1, Psi2, Psi3. We standardize them and we multiply them, and it is in 9 different interaction terms. And we are using these interaction terms as just as a single variable, and that variable is known as the interaction term. Okay. Next approach, it is similar to the product indicator approach. Okay, but there is slight difference here. Okay, and that difference is very important to understand. And that technique is called orthogonalization. And this orthogonalization technique it's basically an important this is known as 2-stage OLS procedure, 2-stage OLS procedure. Okay, so product term and orthogonalization, somehow they are the part of the 2-stage OLS procedure. Okay, in traditional approaches which are used for testing moderation hypothesis, we mean center or we standardize the independent and the predictor variables. Okay, but the problem with these approaches is that they still the issue of multicollinearity may still exist. How? The mean center product or power term will still have some degree of correlation with its first order variables because we multiplied those indicators together. Okay, so they may still have some kind of association or correlation with each other, and this is something that can lead to the issue of multicollinearity, and multicollinearity may still persist. Although we mean centered these variables, this is somehow effective technique for reducing the issue of multicollinearity, but in fact it is very, you know, still the issue of multicollinearity is not completely eliminated. It may still exist. Okay, so the problem of multicollinearity, for which we standardized or mean centered the variables, it might still persist. So what is the remedy? The remedy is that we have to try to completely eliminate the non-essential multicollinearity in the regression analysis. How we do that? We can do that by using some residual centering. Residual centering, it basically, it is a process that ensures full orthogonality between a product term and its first order effects. So here there are certain terms. What does it mean by orthogonalization? Orthogonalization, it means that the two variables, they are least coordinated, or they are not sharing any variance with each other. Okay, you know, in moderation analysis, how we create the product term, or how do we create the interaction term? By multiplying the independent and the dependent variable estimates. Okay, so this is something. So in fact, interaction term is created because of its first order, you know, values, first order effects. Okay, so how we do that residual centering, this is something that I want to give you a quick demo here. Okay, it is almost same approach. The first two first 2 points are quite same, that we standardize the variables and we multiply them with each other. But after multiplying them, okay, we have to use a different specific procedure. Okay, in fact, why we have to consider orthogonalization? Because it reduces the issue of multicollinearity, and we can get more, you know, unbiased results. Okay, where, because the residuals will be orthogonal, they will be sharing minimum variance with the indicators of their predictor or moderating variables. Okay, how this happen? It is the same. Here you can see the steps are, I'm now introducing you with different steps which we can use for the purpose of performing orthogonalization. Okay, and it is the same first step that we performed in the product indicator approach. Okay, what was the approach? In fact, we multiplied the observed variables, okay, of the independent and the predictor variables with each other, and we created 9 different interaction terms. Okay, but the next step is quite different. The second step here, what we have to do, okay, we have to basically now regress all of these interaction terms with all of the, you know, products of these these different variables. How? For here you can see in the diagram, in the first step we created, in this specific data file, you can see in the first step we created interaction terms. Okay, once we have created all these interaction terms, the next step that we have to perform is that we have to create residuals. Okay, how can we create residuals? There are a variety of tutorials available on YouTube, but I will give you a very simple and brief overview here. Here, what we shall do, we'll take the first interaction term, okay, and we shall regress it on all of the indicators of mediator and the moderators, okay, given here. Okay, and we can, how can we do that? We can click on save, and we click here on standardized, and we click on continue. Okay, and we repeat this specific procedure with all of these 9 different interaction terms created here. So there is just one addition, one difference between product indicator approach and the orthogonalization, and that difference is in front of you here. Okay, we create product interaction terms by multiplying the indicators of different variables, and then we regress those interaction terms with on the all 3 different indicators of the moderator and the mediator together. Okay, and we press OK. When we press OK, you will see in the data file, I have already computed, but again, they have been computed, okay? Here you will see that a set of, different residuals, they are represented here. Their name is, in this, 9 different residuals will be added, okay, one by one. You have to perform the same procedure with all of these interaction terms. In previous step, you have 9 interaction terms, okay? So after after performing the process of creating different residuals, we shall repeat the same procedure with all of them, and we will have 9 different residuals based on the this specific process. Okay, just like we had 9 different interaction terms. Okay, once you have done that, okay, we have to now use these residuals, these 9 different residuals, as an indicator of our our interaction term. So the difference between previous indicator term here, you see in this specific example here, we are simply multiplying and we are using interaction terms as indicator of the interaction term. Okay, the latent variable of interaction term, we are only using the interaction terms, but here we don't have to use interaction terms only, rather we have to use the residuals of these interaction terms as the indicators of the latent variable that is known as the interaction term. So we create interaction term through different procedures. In the SPSS, in stepwise hierarchical regression model, we simply multiplied the singular mean computed values of the independent and the moderated variable. We standardized them and we multiplied them together, and this is how we obtained interaction term. In product indicator approach, we obtained this interaction term by multiplying the standardized values of all of the indicators of the latent variables of predictor and the moderating variables. Okay, but in orthogonalization, we go one step ahead and we create residuals based on the regressing, based on the process of regressing interaction term on all of the 9 indicators of both moderator and the predictor. Okay, this is the key difference between different approaches of moderation analysis. So if someone questions you that how can we differentiate these different approaches, the basic idea is that it is the way you try to compute the interaction term. Okay, and in SPSS does not allow the use of multiple latent variables, but AMOS and other structural equation modelings, they allow us to use latent variables as predictors, moderators, or interaction terms. Okay, so in product indicator approach and in orthogonalization, we create interaction terms differently as we create in hierarchical regression. Okay, and the regression, the equation of this specific regression is also given here on this specific slide, as you can see, if you want to see its model. Okay, interaction term which we created by multiplying first indicator of incivility and the first indicator of psychopathy. It is basically regressed on all these different 6 items. 3 items of psychopathy and 3 items or variables of the incivility. Okay, and when we regress, we get some kind of residuals. Okay, and we repeat this specific process with all of the 9 different interaction terms. I hope you have obtained the idea, basic idea that basically helps us in differentiating between different types of moderation analysis approaches, moderation approaches. Okay, the fourth.
Dr. Ali?
Yes.
Dr. Ali, I just want to remind about the time. It's 6:10.
Okay.
Just remind about the time only. But it's okay if you want to proceed.
I will try to complete it as end it, because the if we leave it in the middle, then you know the
Sure.
topic will not be complete. So I have to
Sure,
try to
sure,
complete.
Doctor.
Okay. Okay. The
Sure.
fourth approach
All
is
right.
the analysis of variance approach, and this approach is comes under the you know umbrella of general linear model or the general multivariate regression model. The advantage of analysis of variance is that it allows us to use multiple dependent variables. And what we do in this specific approach, we try to compare the variance between different groups with the variability within the each specific group. So when we have variables just like age, we have categorical or we have ordinal type of variables, it is better to use the go for analysis of variance. Okay, in analysis of variance, it's another advantage is basically we get something that is known as F ratio, and F ratio is calculated by dividing the variance between groups and dividing it with the variance within the different groups. Its another advantage is that it also provides us the effect size, means what is the strength of moderation. Okay, having interaction terms significant is just one indicator of the significant moderation moderation goal of the moderator, but it's what is the strength of that specific variable. It can be determined by using the effect size. Another approach, a benefit of analysis of variance is that it can help us in using the post hoc analysis. Post hoc analysis means we can compare every group with each other. For example, if you are interested in determining the mean value of academic performance of male and female students, so you can perform the post hoc analysis and you can get separate values for each of the specific group. Okay, and the next approach here, this is the just graphical you know I have used this slide to just provide a brief demonstration. In SPSS we can use ANOVA using these two different you know what we call it sorry, okay, we can use these two different options for the sake of you know sorry, general linear model and generalized linear models. These two different you know options for performing moderation analysis using the approach of ANOVA. There are different types of ANOVA: one-way ANOVA, multivariate ANOVA, two-way between group ANOVA, mixed between, and all of these types of ANOVA can be used for the purpose of performing moderation analysis, and they provide a very you know detailed analysis of for comparing different groups. Particularly here, ANCOVA and MANCOVA, these are the two specific types of ANOVA which are used when you are using some kind of control groups. Just like in an experimental studies, you're using different kind of control groups, okay, to compare the effect of your treatment that you are introducing, okay. And then another method is the mode probe method. This mode probe method, it has become now part of the process macro, which basically which Preacher and Hayes introduced previously. Its plugin was also available, and it was basically an aid for probing single degree of freedom interactions in OLS and logistic regressions. Okay, I have provided this specific link on the on this specific slide. If someone wants to basically if someone wants to install this specific, this plugin is still available. Okay, here for example, just for the sake of demonstration, I don't think if the majority of students, they have complete idea about this specific option, but on my computer, I have already installed this, you know, plugin in under the, you know, caption of linear regression here. Okay, so this plugin is available on this specific website. You can easily go and you can install this plugin in your existing you know SPSS. That is separately also available, but now it has become part of the you know moderation analysis process macro. Okay. So the last thing that I have to discuss, the last approach is the group analysis approach. Group analysis approach can be used in almost every type of the software. For example, in SPSS here, just like while we were performing the moderation analysis here, you can see there is a variable that is known as the selection variable. You can click here and you can enter the values of your group variable, and it will provide you results with respect to the groups. For example, if you are interested in examining the relationship between intelligence and academic performance of male and female students, so you can use gender as a group variable, and you can examine this relationship between them. Okay. Similarly, in structural equation modeling, here I have provided an example, a pictorial example of the AMOS, that is software that is used for the purpose of structural equation modeling. Here you can in AMOS you can create different groups here, and then you can assign the same data file, and you can define the values of groups, and then you can perform the analysis and you can compare the results of those groups together. Okay. So the last thing that I have to discuss is that, in fact, once you have found that the interaction term was significant or it was not significant, you can also generate a graphical representation of the moderation analysis. And for this, I have again provided you different, these links, and which you can use, particularly James Gaskin, who is very renowned person these days for the sake of basic understanding of structural equation modeling. He has created an Excel sheet that can be downloaded from this website, and on this website you can use the standardized regression estimates in order to create this specific plot here. Here you can see there are two different lines, and this graph is explaining the relationship between two variables based on third variable, that is the moderator, and these two lines are crossing each other. A general indicator that is used, that these two lines should cross each other in case you have a significant moderator. If the moderation was not significant, these lines don't cross each other, rather they go parallel to each other. Okay, so once you have found your moderation analysis significant, you have to create a plot. Plots are very helpful for demonstrating the significant interaction effects, and they are also very friendly for the reviewers and the editors, and they like to see such things in the research papers. Okay, so till now I have tried to cover all these topics in quite brief in relatively brief detail. Okay, and the message for the audience or the participants is that if they want more hands-on experience about all of these specific techniques, we can organize a separate workshop that prolongs more than 1 hour, just like today's. This was just a basic understanding I wanted to provide to the scholars of research. So now all the queries on behalf of the participants, if some, I would welcome the queries. You can raise your questions, and I'm available for you to provide answers for the queries which are in your mind.
All right, so thank you so much to Prof. Dr. Ali. So now there's an answer and question session. If there's any participant would like to ask further questions to Prof, you may ask currently. Or maybe you can leave the questions in the chat box.
Yes. If you have any queries, you can either directly ask the questions. Otherwise, you can leave your questions in the chat box. At the same time, you can also leave your comments in the, the links that were shared with you using different social media websites, just like Facebook. Okay, you can leave your comments, and I would feel very happy to answer all these specific questions.
Is there any question from the participants?
Yes, I have a question.
Have a question.
Yes.
So my question is, please, can we use this analysis method to integrate two different components together?
Different components.
For example, for example, I have total quality management and building information modeling. So I have gathered my data that I need. I have put them in SPSS. So can I use this PLS model to integrate the two entities together?
Okay. You want to, you are using either one of them as a moderator?
No, I'm not using either of them as a moderator, but I want to integrate the two to improve the quality. So quality is my outcome.
Quality is outcome variable, and what is the predictor and what is the moderator? We use moderation analysis only when we have moderation hypothesis. If you are simply interested in the relationship between two variables, that is the direct relationship or simple relationship, okay, then you don't have to integrate them. You have to examine their relationship separately. Even so, for the in simple, if you do not have moderation hypothesis, means you're not interested in understanding the relationship between two variables across different levels of a third variable, then you don't have to you don't have to create interaction term. You don't have to integrate them. Okay.
So in this case, if my moderation variable is the construction industry, then the two variables are the total quality management and building information modeling. So the construction industry is my moderation variable. So is it possible to integrate them now?
Yes, in such scenario, you can use industry as a moderating variable. Okay, and you can basically do this by either you have to now it depends, the better approach, how many industries, the effect of how many industries you want to see, how many groups you have in the industry, single or multiple, how many?
We have 7 groups in the industry.
7 groups. So in such kind of scenario, 7. One option that you can use, you can either go for the group analysis. If you will go for group analysis, you can get separate beta coefficients. Otherwise, that is more suitable because the nature of your variable is kind of, categorical. Okay. Otherwise, you can use this specific variable as you can also introduce industry. You have to standardize it. You have to create it into different levels, but it would be quite complex to use, regression here. Okay. So either go for the group-wise analysis using AMOS. Okay, and you can integrate orthogonalization with the group analysis. You can perform orthogonalization, okay, but group analysis is the most appropriate, statistical technique. Okay, so you can create a structural equation modeling. You can create a structural regression model in AMOS or any other structural equation modeling tool, and you can create different groups. And then you can observe the beta coefficients with respect to each groups in your industry. So you have to create 7 different groups here, just like we created different groups here in AMOS. Here you have to create 7 different groups. Okay. That's right. You have to create 7 different groups. You can build a model like this.
Thank you very much.
Yeah,
thank you
that
very much,
model
Doctor.
should not include
I really
interaction
appreciate
term. Yeah. Please, next question.
Dr. Day has chatted the question in the chat. You want me to read or?
Thank you very much. I really appreciate it. Thank you very much.
Welcome.
Thank you, Abdul Rahman.
In the chat, let me check. Where is that? Just a second, please. How can I reach
Maybe
it?
you can
Chat
scroll a little bit down.
little bit down.
Yeah, starting from how do we differentiate between one-way
Okay,
ANOVA and
okay.
two-way?
Okay, yes, I have questions. I will have both mediate and moderated variables in my study. Please recommend good article to enable. Okay, for moderated mediation, okay, you can, Preacher and Hayes, they have already, published some articles. I can share the articles. If you send me an email, I will share this specific art. You have to study articles related to the moderated mediation. If you have both mediator and moderator in your study, okay, you have to study the articles related to the moderated mediation. And Preacher and Hayes, they have already published some, a lot of papers. Okay, if you send me an email, I will share it with you. Okay, and any other question, please? Yes, sure. My contact details are with the moderators of this specific, with the specific uh, conference representatives, okay, and particularly doctors who organized, who moderated initially, and our current moderator. Okay, I can provide my email address and my contact number, and you can get it from them. Okay, please, any other question if you have?
I think there are a few in the chat box.
Okay,
So,
I have shared my email address and my contact if you want to have. These are my details. If someone is interested, you can send me an email. You can also send me email via ResearchGate, okay, or the Google Scholar, any others, Any other question,
yeah.
please? I know this was a quite, a hasty kind of talk, but I had to cover a lot of things. So that is why I was, feeling.
Yeah, and also the limitation of the time, 1 hour, right? So I think if you guys have any other further questions regarding this analysis, maybe you can directly email to Prof. Ali as
I
well.
got one question here. Sorry to interrupt you.
Yeah, sure.
It is from Suhaila Basir. Okay, the orthogonalization and the interaction term sound so difficult to understand. Okay, so just let me go back to this slide here, just for the sake of repetition. Okay, in fact, once again, first of all, we create interaction terms, okay, using we create interaction terms. This is the step one here, okay, and after creating interaction terms, we have to create the residuals of these interaction terms. And how can we create residuals? Residuals means error terms, okay. And how can we produce these residuals? By regressing each of this interaction term with all of these variables. I'm repeating this process again. In the first step, we multiplied these six different variables with each other. Okay, these are observed variables, or these are the indicators of these two different variables. In the first step, we multiply all of them, okay, and when we multiply them one by one, okay, we get 9 different interaction terms. Once we have obtained 9 different interaction terms, now we have to regress each of these interaction term, okay, on all of these 6 variables. When we regress them, we can obtain the residual variables. These residuals, or the error terms, are created automatically in SPSS as some new, you know, as new variables in your data file. So you simply have to use linear regression option.